Hi, everyone. I'm excited to be here. I hope you're all awake because this is going to be very hard. No, just kidding. So I'm going to be talking about how we provision Kubernetes clusters in the cloud and on-premise using meshStack. So about me, I know Christina already said something about me, but I'm Julia. Hello. I actually don't have an IT background. I'm an engineer. But yeah, people can change. You can learn new stuff. So for the last 4 years, I've been working in the cloud native environment, and 3 of those years at IIV. In the, like, we call ourselves the Everything Cloud Native department. Of course, the department has an official boring name, but that's basically what we do. And also that name changes all the time. And there I'm an Azure admin and also a meshStack admin and platform engineer. But what is IAV? I know I already talked to some of you about it, like what do we do yesterday? But yeah, we're not that well known. We're an engineering partner in the automotive industry, and we've existed for quite some time, since the 80s, when a lot of automotive engineering was cogs and engines, and that still exists to some point, but there's been a shift in the industry for the last decades, and innovation happens a lot more in software than in cogs and engines. So we've shifted towards more software engineering, and that's why also cloud topics have become much more relevant. And our department is in charge of setting up and managing access to everything cloud. And that's how we got into meshcloud as well. So we're using meshcloud, the meshStack. First of all, for like the classic features, we provision AWS cluster, AWS accounts, and Azure subscriptions for our like internal customers or colleagues. But we're all, and that works very well. But that's not what I'm talking about today, because we're also using building blocks a lot, especially for provisioning standalone services. So not as an add-on to an existing cloud account, but in order to provision a service. So we have a virtual machine service. You can create DNS subdomains and records, and S3 buckets, and you can talk about all of these to me later if you want to. But today we're talking about the Kubernetes clusters that we also provide as a building block. So this is like the most basic image I could come up with. What we actually do. So we have a building block, and that building block deploys a cluster. Of course, it's much more complicated, and we're going to get into it. But basically, the building block, you trigger it, and then that it deploys EC2 instances in AWS, and those are then used to create a cluster, a rancher cluster. And I'm going to talk about what that means as well. But you might have a few questions. The first would be, like, if you use AWS, why not just use EKS? That would be so much easier. You could just say, okay, Terraform or OpenTofu, create an EKS cluster, apply, done. Why create the EC2 instances? Why go through all this trouble? And the main reason is we want everything to be the same in each cloud. So the goal is to be cloud-agnostic in our Kubernetes clusters. So we don't want to use the AWS flavor. We don't want to use the Azure flavor. We want to have the same Kubernetes flavor in each environment, so that it's also much easier to shift between the different environments. And so yeah, we already use Rancher on-premise. That's why we said, okay, let's also do Rancher in the cloud. But what is Rancher? What is that weird cow? So Rancher is an open source platform for managing Kubernetes at scale. And they have a bunch of different features. But the ones that we like most and use most is like you have a centralized place for all clusters. So you have like a central rancher cluster that manages all other clusters that you spawn. And this central cluster also provides you with a UI where you can see can you see the mouse? No, that doesn't really work. Okay, so yeah, in the screenshots you can see like an overview over all the clusters. You can also see the workload that's there, and also not just from an admin perspective, but also from a developer perspective. You can also deploy stuff, you can check in on your applications, and all that through the UI. Of course, it's not the fastest way to administrate a cluster or to work with a cluster, but especially for newbies or just developers that are not as into infrastructure, this is like a very low effort way to start. So that's what we love about it. And we use it because of all those things that we like about it, but also because we were already using it for existing clusters. So people already know it. And our developers also really like it, some of them at least. And it's the same in every cloud, as I said. Okay, so now we talked about why Rancher, why not EKS. But let's go into more detail. Let's detail this picture. So that was like our image, and then we started to build it, and we learned a few things. So let's get into it. The first thing that we learned was that it makes sense to use a custom platform in meshStack. So like the classic building block use would be you have, for example, an AWS account that's a tenant in meshStack, and then you add a building block to that account. So you deploy into that cloud tenant that's already there, that's deployed through meshStack as well. But we wanted to create a standalone service. We wanted people to be able to just get the cluster without the account, because like some people don't want to mess with that. And that doesn't work. So you would always need a cloud tenant for the setup. That's why we decided to use a custom platform with a landing zone. So we have a platform that's called Kubernetes, and you create the building block and the tenant at the same time. So you still need to create a tenant because it's a tenant building block. Also, we built these before workspace building blocks were a thing. So the building block actually creates the tenant at the same time. You only have one step, and you don't need a separate cloud tenant. So this works very well for us. It's a little bit more effort to set it up, and you need to, like, as an admin, you need to get into what is a custom platform and how do I manage that, but it's not that hard, and you only need to do it once. Then the second thing we learned was it makes sense to use to move user management to its own building block. So the way we do it is that we take all the permissions that are on the project. So all the users that are assigned to the project and their roles, we take those and we apply them to the cluster. And there's a handy little variable that you can use as input for building blocks. That's called permissions, and we use that. But then the problem is a building block is run each time a variable changes. So every time a user assignment changes, the building block is run again. And even if nothing really changes, only this one user assignment, a pipeline for a huge cluster like that, even if nothing changes, still takes quite a long time, and it's just unnecessary. So we didn't want that. So we decided to move the user permissions to another building block and have like one cluster building block and one user management building block. So the cluster building block is only run once in the beginning when you create it, and then the user management building block is run each time a permission changes. And what's important when setting this up is that you, of course, need a dependency between the user management building block and the main building block, because if you try to assign users to a cluster that doesn't exist yet, you run into problems. Then the third thing we learned was that it makes sense to use a CI/CD tool for deployment. I know now we have like native Git building blocks and GitHub building blocks in meshStack. When we started, that didn't exist yet. So we only had the classic Terraform building blocks. And if you use them as they're like designed to be used, then it's very easy to start. You just need a repo with some Terraform code, and then you run that. But the problem is that you run into problems as soon as you do something that's not natively Terraform. So we started wrapping shell commands in Terraform, and it's not made for that. It does very weird things, and it's just really ugly. So you don't want to do that. You also don't have much control over which tools are installed in the runner. I know you can get also custom runners for meshStack, but it's just you have less control over what's installed, and it's just a pain. And also, if you want to use, for example, an internal vault instance for secret management, it might be configured in a way that is not accessible from meshStack, so it's easier to shift that access to somewhere internal. And that's why we said, okay, we're gonna use a GitLab building block. We're gonna trigger a GitLab pipeline from the building block, and then we're using GitLab for almost everything. So we have a lot of expertise already in how to build GitLab pipelines. We have a lot of pre-configured building blocks for pipelines in GitLab. So that's like a huge plus. Also, it's much easier to configure the environment that everything runs in. We also know how to do that easily. You have better access to internal resources, and you have to store less secrets in meshStack, which is, secrets in meshStack are encrypted. That's not really the problem, but I found it hard to keep track of like what is the value of these secrets right now, because once they're encrypted, you can't read them anymore. And then when you want to switch out the secrets, it's a whole thing, especially if you're managing a lot of building block definitions. So the only thing that's kind of a downside is that it's a bit more configuration in the beginning, but especially now that the native GitLab building blocks exist, it's not really an issue anymore. Okay, so that's not everything we learned, but the big three things. So let's look at what we ended up with when doing all of that. So we have a Kubernetes tenant in our custom platform. And in that tenant, we create a building block that deploys the Kubernetes cluster. And that one triggers a GitLab pipeline. The GitLab pipeline creates the cluster, and that cluster is connected to Rancher, like the Rancher main cluster. And then when that is done, a second building block is run. Come on. There you go. For the user management, and that's basically the same. It triggers a GitLab pipeline, and that GitLab pipeline manages access to the cluster. Yeah. And like if you don't understand anything anymore, you can also ask questions in between. So I've prepared a little demo, and because I'm afraid of live demos, and also the pipeline might run for up to 30 minutes. Oftentimes it's quicker, but yeah. I prepared a little video. So here we're in our meshStack, and you can see like in the marketplace, everything that we have. You can also see the DNS stuff, the S3, but we want to get a Kubernetes cluster. You need to create a new project. Let's just choose any boring name. Let's do production cluster. And yeah, this is just like billing information. Here you can see that the tenant is created at the same time. Now the configuration for the Kubernetes main building block, we have to input a cost center, but that's just our thing. And then you can choose some configuration. So for example, you can decide if you want Kyverno installed. That's a security tool. You can choose how many master nodes you want, how many worker nodes you want, and also the size of those nodes. And I'm just going to choose the rather low numbers just because this is just for a test. So just the medium ones. The rest I'm going to leave the way it is. Then there's the user management building block, but you don't need to configure anything for that. You just need to add yourself as a user here. Next. And then once you create the project, you can see that the tenant is created. And you can also already see that the 2 building blocks are inside. Now, if we click on the detailed view, you can see it even better. Like the cluster building block is still running, and the user management building block is waiting because of the dependency. And here you can see the pipeline view. So the pipeline has been triggered, and like if you look at the logs, you can see that some OpenTofu stuff is running. So now we're gonna go and skip some time. So now it's all done. And now when it's all done, and you reload the page, you can click on the link there, sign into Web Console, and you're redirected to the Rancher front end. And you can just, like, we connected it to Entra ID, so you can log in with your normal user credentials. And then in the front end, in the Rancher front end, you can see your cluster. And it's still in an updating state because it was new, but now it's all there, and you can see the nodes. You can see the workload, so you can see that there's the Kyverno installed, just like we wanted it to be, but nothing else. So now you're free to use it. You can also copy your kubeconfig from the Rancher front end. And yeah, there's your cluster. And now we're starting on the top. So yeah, that's how it looks from a user perspective. And I talked about AWS a lot, but if you remember the title of the talk, on-premise and in the cloud. So what about on-premise? Why haven't I talked about this yet? And one of the reasons is it's basically the same. So I don't need to explain a lot more. We're doing the same stuff. We're using Rancher. We have a custom platform. We are using 2 building blocks. We have a GitLab pipeline. The only difference is that we're using our internal OpenStack instead of AWS. And that's it. And then there's a tiny second reason why I didn't talk about it, because the building block is not released yet, but it will be soon. So I wouldn't have been able to show you a demo. Yeah. Thank you for your attention.